Good morning, everybody. My name is Rogério Simões, and it is my pleasure to share this technical section of the first FibEnTech International Congress. To open the section, I would like to greet the invited speaker, Professor Naceur Belgacem. It's a pleasure to be with us, and also the other four speakers, Bruno Escobar, Anabela Rebelo, Faléstine, Souiad, and Josivaldo Satter, and also the audience. Before to introduce our invited speaker, I would like to start giving an overview of this section. These sections are two different parts. The first one is devoted to the surface functionalization of cellulose fibers, and will be presented by the invited speaker, Professor Naceur Belgacem. The other four presentations are about effluent treatment, water treatment, and risk assessment of water use. We have two presentations about utilization of algae-bacteria consortium to carry out effluent treatment and recover the biomass. One presentation about a semi-quantitative model to perform risk assessment for water resources. And one presentation is about the utilization of a natural scale inhibitor to treat hard waters. After this short overview of the technical section, it's my honor to introduce the invited speaker, Professor Mohamed Naceur Belgacem. Professor Naceur Belgacem received his engineer degree in wood science and at the St. Petersburg Forest Academy in 1986. He then got a PhD in material engineering and science from the Polytechnic Institute of Grenoble, France in 1991. He was then awarded in a fellowship for the National Research Council of Canada to carry out a postdoctoral training for 2 years in the Polytechnic School of Montreal as a researcher in the field of surface and interface phenomena in cellulose-based composite materials. On his return, he worked in research and development departments in the industry for 5 years before moving to University of Beira Interior, where he spent 3 years from 1997 to 2000 as an associate professor. Professor Belgacem was nominated full professor in 2000 at the Polytechnic Institute of Grenoble, France. He has published over 350 scientific papers, including 2 books and about 25 book chapters with around 13,000 citations. He has a H-index over 62. Professor Belgacem is one of the 3 editor-in-chief of Elsevier Journal, Industrial Crops and Products. And nowadays, Professor Naceur is the head of the International School of Paper, Printing Media and Biomaterials at Grenoble. So it's my pleasure to have Professor Naceur, and you can start. Thank you.
Thank you very much, Rogério. I am very, very happy to be with you. It is a great pleasure. I was once in my life a permanent staff, permanent people in the staff of Departamento de Papel of Beira, University of Beira Interior, and it is very, very pleasure for me to share with you some of our work and last and recent developments in what we are dealing with. Of course, I would like to thank the organizing committee for giving me this opportunity to talk about our work. And of course, I would like to compliment all my friends there. Of course, I have forgotten a little bit of Portuguese, so I will remain in English such a way that every people will understand what I would like to tell you. So let's start with my presentation. I would like to talk about the surface functionalization of cellulose fibers. And first of all, I would like to introduce the context before moving to some aspects of chemistry of such a wonderful macromolecule before giving you some concrete examples of applications. So let's see what people is looking for today. Is the society expectation are mainly focused on the fact that people would like to have more functionalities, safe environment around, and light products. The more functions, typically you have it in your smartphone or iPhone, and you see how many new functions this device have get the last 20 years. And at the same time, you know that this device have lost a lot of weight. He gained much functionalities and became lighter. As soon as you have this expectation, then you in order to get something light, something sustainable, something bio, you have no way to escape the nature. The nature produce it's a big reactor of vegetal biomass, animal also, but let's stay in vegetal biomass, in which there is a very simple reaction, very let's say in organic chemistry, very simple products like carbon dioxide, water, and then you have, thanks to solar energy, millions, thousands of molecules, macromolecules, and so on. This is mainly because it is not a simple chemistry. It is a chemistry which is associated by enzyme and so on. Now, if you look a little bit for what the nature is giving us, in order to have an idea about what our possibilities, what we will have tomorrow in our hands, the vegetal biomass is one of the most produced material in the earth. 300 billions of tons each year. I'm talking just by the production of photosynthesis. I'm not talking about the capital. This is the babies of vegetal biomass, which is given every year. Most of them are wood, such a way that you have most of the products produced are polysaccharides. Moreover, normally, let's say it is better to think wood because annual plants are mainly and mostly used for food streams, such a way that from ethical point of view, it is much better to limit their use, at least use only the residue they can produce. So as I told you, 75% of the major part of biomass is cellulose and hemicellulose, is mainly sugars. I believe that tomorrow the chemistry will be a sugar chemistry. At the same time, if you try to discuss about versus fossil resources, then you will see that we are consuming 4,000 millions of tons of oils each year, and the oil reserve, even if there is a lot of discussion about the number of years which are still available for us, it doesn't matter. It is few decades at least. Even if it is 2 or 3 centuries, it's nothing to compare with the life and for human in the earth. Moreover, the major part of this oil is used for energy. It's used for our cars, for heating, and so on. And if we look a little bit about the organic chemicals which are used in pharmacy and so on, they are mostly oil-based. So let's say that generally speaking, the rest of the 10% of oil which is used in addition to the 90% of energy is mostly, let's say, for plastics, synthetic polymers, and fine chemistry. So the idea is to ask ourselves, is it credible to have a biomass at least partially to replace oil? So if yes, for which of the application? Is it more for energy or for chemistry? I believe that for chemistry, at least, it is probably worth to think about. So if we move a little bit later, and as I told you, you see here we have cellulose, which is embedded by lignin, and this is the wall of vegetal biomass. So let's see what we have in there. We have their macromolecules, which could display themselves in several sizes, from the macromolecule itself to fibers. So we have cellulose at several scales, from the cellulose itself, which was used, the first one with the first macromolecules exploited was cellulose, because we produced from it cellulose acetates and other derivatives and so on. So cellulose not only can be available as a macromolecule, but it can be available as a structural materials from nanoscale to macro scale. What is interesting also in cellulose is the fact that it contains hydroxy functions. And hydroxy functions are very suitable functions for people who knows organic chemistry, because you can make a lot of chemical reaction to provide these marvelous macromolecules some new functionalities, at least when you are looking for covalent bonding. So I will not bore you about the fact that which are the variety of molecules you can graft at the surface of cellulose. And when I'm telling grafting, it is not physical adsorption, but real grafting, at least ionic or covalent bonding. But it merits, let's say, a presentation itself. So I will just show you the picture, which gives you all the possibility which were tested in this context. If we need more details, then we will postpone this discussion for another occasion. So let me give you some examples about this possibility of providing cellulose some functionalities. First, what we should emphasize is the fact that we are using cellulose as substrate, and we will try to never destroy its semicrystalline structure, and we'll try to limit any of our reaction to the surface, strictly to the surface, because we need these structural properties of cellulose fibers or nanofibers and so on. It is totally different to compare with what is very well known cellulose derivatives, in which you are dissolving everything. Here we are trying to keep the fiber or the nanofiber, the microfiber integrity. So if I will give you 3 examples, and since Rogério asked me to limit the discussion to 25-30 minutes, I will try to stick with, in order to give you the possibility of asking me questions if there is any. The first example I will give you is active packaging and it will be given for 2 options. The first option is release mechanism, and a little bit later I will speak about contact mechanism. So it means that it doesn't matter if you are using nanocellulose, microfibrillated cellulose, or something which could be interesting for cellulose is the impregnation or the physical mixing of any active molecules inside, in bulk, or at the surface of cellulose fiber mat. And if you succeed to do so, which is very simple because it is pure physical mixture, what is relevant, what is then became the challenge is how can we release it with a controlled manner, such a way that we prolong, we give higher shelf life of these active surfaces. And in this context, we tried several concentrations. We have used cyclodextrines, in which we absorbed some antimicrobial molecules, and we tried to see the mechanism of release, the mechanism of inhibition of microbes, and with just by playing with the way of forming the fiber mat, we can have several, let's say, kinetics of release of such molecules. Of course, we have used the model compounds like caffeine, but of course, then we have used more adequate molecules, which were inserted properly in cyclodextrin molecules. And to give you the last step of examples, sorry, it is not animated, but okay. Just to show you, I don't know why it was converted to PDF, because we have an animation, but I will not lose time in. But the only thing I would like to show you is if we pack something which is known to undergo biological degradation very fastly, like pork liver, depending in the way of packing it in classical cardboard, polyethylene coated one, or our functionalized, what we have seen is we have a much better preservation in the case of our functionalized surfaces if we compare to classical cardboards. So it is very interesting without any destruction of mechanical properties, without any destruction of the fact that it is still biodegradable, which is in contradiction with the product, which is with polyethylene, and bio-based, of course, and of course light product. The second example I give you concerns contact mechanism. Contact mechanism meaning that this is mainly due to the fact that in nosocomial diseases, which are a big challenge in hospitals, we have in Europe at least 75,000 people which are dying each year just because of this contamination on hospitals. And the contamination on hospitals is driven by the fact that a doctor or a nurse is working, she could have a contamination in her hand, and as soon as she will look for in a package, in a box for a syringe or for any medicine, she will leave these microbes at the surface of this box, and then you have a extremely fast transfer, because you have another one who will use this box and he will be contaminated and so on. The idea was to graft chemically penicillin on the surface of the box, such a way that when people is touching these surfaces, the microbes are killed by penicillin. Of course, the idea of grafting penicillin chemically is extremely important, because it is if not, people will be contaminated by this penicillin, especially medical staff, and they will develop resistance to microbial or antibiotics. So of course we have designed something in which we graft. The idea here is the fact that we have a carboxy group. We could make esterification of the surface, but we have this showed that there is the grafting indeed occur, and we tried, of course, to have some tests for this contact antimicrobial surfaces. But what was very interesting is the fact that we went to the production of few tens of thousands of boxes which we printed with this active surface, and we have tested them in hospitals in order to see if there is something worth to go further. For now, it is still under discussions and so on, and you know that in health context, it is very long time. It takes long time to be used as a classical product. The last example I will give you, and I think I will stick in the 25 minutes which were allowed to me, is the another example in which we are using cellulose as a let's say at the surface of medicine. There is a big problem in people who get chirurgical operation, and he gets a lot of troubles after this chirurgical operation, because they have infections. Of course, the medicine was really, let's say, increases our life expectancy. As you see, for example, in a little bit more than 1 century, people have gained a lot of years, such a way that, of course, we get also such a lot of some diseases which require chirurgical operations, and each year 5% of patients get infections after the operations. And when you have infection, you need to open again the patient. You need an operation which will cost time, money, which will cost suffer for the patient, and so on. And the idea was the following. We know that one of the biggest problems with this operation is the operation associated with hernia, inguinal hernia, which is just a default of the tissue, and we, in order to repair this default, we just made practically as by simple let's say network of cellulose or polyethylene terephthalate, and then it is fixed, and the organs which were outside their places, they come back to the and it is quite simple operation, but after this operation, a lot of cases, the second problem of this operation is the provocation of how to say infections. And what we have decided to test with our colleagues from medical fields is to functionalize this mesh before implantation, and to functionalize such a way that if there is an infection, then you have an in situ release of antibiotic which will kill the infection. Okay, so and this is of course the release should be driven only when the infection is there. Such a way that we did some grafting at the surface of cellulose fibers, but the grafts was not with the drug itself, but with what we would call with the prodrug, which means the prodrug is this one, but the drug which will repair the infection is only this one. And this link, this ester link, will cleave only if there is infection, because if there is infection, you will have the enzyme which will hydrolyze this ester bond. So we did. This is schematic presentation. It means only if when you have enzyme, they will release of this molecule which will kill the infection. Okay. Of course, we did everything we know how to do in labs in terms of chemistry. We functionalize our meshes and tissues, textile, PET. Textile, we work a lot of textile with textile. PET is much more complicated to graft. We tried to see by NMR that it is the grafting had indeed occur, carbon-13 NMR and other techniques. And then we tried to see, okay, let's say we have the tissue which is functionalized. We tried to see as a reference without anything, and here we try to add the enzyme. And we see by chromatography, by liquid chromatography, that the enzyme indeed break this link and release metronidazole, which is the molecule needed to kill the infections, and which was not grafted as such. It was grafted with another part of the molecule, such a way that there is no release of this molecule if there is no infection. Of course, we try to do it also with in vitro tests, which work quite well, at least according to the comments of our colleagues in medicine. And of course, as you see, as you know, these molecules and this science will take a little bit time before going an industrial reality, because you need also in vivo tests in rats, then in pigs, and so on and so on. So it takes time. So these are the examples I have chosen to you. Of course, we did a lot of other things, and you can consult our publications. You will see that there is a lot of other concepts. There's a lot of other let's say tests and approaches. But what I would like to tell you before leaving the word for my friend Rogério, I think that extremely interesting material, cellulose, in all senses of the term. It is reactive, at the surface. It is upscalable with green approaches. It is very, very well dispersed on water, and it is possible to provide it a lot of properties just by chemical grafting if we work properly. And it could be antimicrobial, it could be fire retardant, it could be for drug release, and so on. So this is an extremely promising material which was used for a long time as a commodity product for paper, for textile. But I believe that it could be used in high added value applications, and I believe that the chemistry of tomorrow will be based on sugar chemistry. And this sugar is mostly contained in polysaccharides, and polysaccharides, as at least the 2/3 of them are coming from cellulose. So, as you know, generally speaking, I know that at the end of any presentation, people try to congratulate the speaker and so on. And in fact, I would like to ask you to congratulate the group of which is working with me. They are the stars. I am just telling what they have done and what they have achieved. So all merits comes to these people. And thank you for your attention, and please come to Grenoble. We have a very, very nice time, very nice views, and you will be always most welcome. Thank you very much.
Thank you, Professor Naceur, for your very nice presentation with some specific examples focused on wealth sectors and wealth applications, which is very interesting. I have here some questions that I will put to you. The first one comes from the audience, and it is about the potential of nanofibrillate cellulose, not for these kind of applications that you refer, but for more general applications, such packaging and replacing the oil-based products. It's the main topics in all these contexts. So the question is, what is your perspective for the use for the utilization of nanofibrillate cellulose to replace some nowadays oil-based products like in packaging?
Yeah, thank you, Rogério, for this question. In fact, nanocellulose was the first expectation from this nanocellulose was people was thinking about mechanical properties, and we have seen that it is not the case. It doesn't bring about really a big jump in these properties, and it is practically the same jump as you can achieve with cationic starch or any other thing. So forget about mechanical. But what is really could be interesting from nanofibrillated cellulose is the barrier properties, barrier to oxygen, namely. It can give really good barrier properties, at least at dry atmosphere. As soon as you increase the humidity, you can have some troubles, and that's why our functionalization is also in this sense. If we have the ability of this network to have some barrier, and if we make them less sensitive to water vapor, then we can probably achieve good barrier properties, as good as those which are achieved by polyethylene or PVA and so on. And this is a good way of replacing, at least partially, these coating layers aiming at providing barrier properties.
Okay. So as we know, the main issue in cellulose is the hydrophilic character. So you need to change from hydrophilic to hydrophobic, and it is the chemist who can help us to move in this way. Consider all these factors. Do you think you need some decades to that these products come to the market, or in the near years we will have this kind of products based on cellulose in the market as commodities?
I think it is a question of years, not of decades, because when we have started working with this, when you need nanocellulose, you should produce it. You cannot buy it. Today you can buy. You have some suppliers. When we started, nobody heard about. Today, I know that a lot of nanocellulose is produced, but for internal use in mills. So they are used, but nobody knows about the use, because they are internally produced and converted as a layers and so on, or as to make better ply bond and between layers and so on. So I think it is a matter of years. I'm sure that it's a matter of years. I can give you some examples like Beauregard, like Arjowiggins, who was really Arjowiggins, who was involved in production of tracing paper végétal. He's working a lot also on this field.
Okay.
With the big quantities, not only with the quantities of lab curiosity, but quantities of
industrial scale.
Yeah.
Okay. Well, thank you very much, my dear friend Naceur, for your nice presentation. It's an honor that you are with us in this conference. Thank you very much. All the best for you.
Algumas palavritas em português, porque algumas palavras são sempre mais lindas em língua da mãe. Muito obrigado para tudo, os amigos ali. Eu claro que tenho muita saudade, estou muito triste de não ter a oportunidade de ver na Covilhã e de passar um pouco de tempo com vocês, mas eu me lembro sempre de vocês. Beijinhos.
Nós também. Grande abraço. Né? Thank you. So we'll proceed with the next four presentations, the next four speakers. We have four speakers. The first one is Bruno Escobar, that we talk about the treatment of industrial effluents by microalgae, Selenastrum, biological and environmental potential assessments is the first one. The second one will be done by Anabela Rebelo from the Portuguese Environment Agency. And the title of the paper is Water Reuse, a Risk Assessment Model for Water Resources. The third one will be presented by Faléstine Souiad from University of Interior, but also from the Department of Chemistry, Faculty of Sciences at Algeria. In the title of the paper is Investigation of Agriculture Waste as Economical and Effective Bioinhibitor for Scaling Inhibitor in Natural Hard Waters. And the fourth one is presented by Josivaldo Satter, that is a PhD student in civil engineer and with us in our university. And the title of the presentation is Opportunities for Microalgae-Bacteria Consortium Application to the Treatment of Effluents Generated in Fiber Waste-Based Recycling Process. So you can go ahead.
Greetings everyone, my name is Bruno Escobar and I'm here to present to you my project entitled Treatment of Industrial Effluents by the Microalgae Selenastrum SCP, a biotechnological and environmental potential assessment, carried out together with my colleagues, the Master André Cunha and Dr. Rogério Simões. However, before we start with the project itself, I would like to show a small summary of what was done in this work so we can have a better sense on what we are going to see later on. The project is started with the production of 4 types of cultures, all with replicates lasting for 8 days, 2 from industrial effluents, textile and paper pulp industries, and 2 controls, with and without glucose, with the addition of glucose serving as a comparison of the effect of dissolved organic carbon on the microalgae in a controlled environment and in a stressful environment. In all tests, nutrients were added, mainly nitrate and phosphate, since the effluents had only a small number of these. And there were also controlled abiotic factors, namely temperature, light intensity, and airflow. At the end of the test, on average, it was obtained a removal of 56.6% of COD and a biomass of 0.45 grams per liter, values that are very close to those obtained in the cultivation with glucose, which were the best considering all the parameters evaluated, with 70% of COD removal and final biomass of 0.51 grams per liter. These values demonstrate the capacity to treat industrial effluents of the microalgae Selenastrum, as well as the accumulation of biocompounds that can be later used for biotechnological applications. But how was it possible to reach these results? Well, to start with, it's important to know that conventional wastewater treatment is not always sustainable and economical, providing only a service that generates expenses and usually no profit. Therefore, new alternatives are always interesting, with microalgae being one of them. The microalgae are unicellular and photosynthetic microorganisms capable of rapid growth and adaptation, in addition to having a wide variety of uses, from effluent treatment to pharmaceuticals. With this in mind, the project of this work was to investigate the adaptation of the microalgae Selenastrum recipe in effluents from the textile and paper pulp industries, its treatment of these effluents, and the accumulation of biomass. The materials used in this project consist of equipments aimed at maintaining and analyzing the cultivation and effluent. As previously mentioned, 4 different trials were carried out, 2 with effluents and 2 with controls, in duplicates lasting for 8 days. There were the addition of nutrients in all tests and a controlled environment, with these values shown here for light intensity and its duration, the temperature, and the airflow. The table to the right demonstrates some of the main characteristics in relation of the chosen effluents, and being the most important one, the COD values. And samples for the analysis of effluents and biomass were collected 4 times during the entire process. The cell volume was estimated considering the shape of the microalgae would be equivalent to a cylinder and 2 hemispheres. Starting then with the COD removal results, we can see that in the graph shown here that there was a sudden degradation of the glucose after 80 hours. A possible explanation is that in the beginning, during the first adaptation and cell growth, the microalgae was in an autotrophic regime, consuming an inorganic carbon coming from the airflow. And when it reached a limitation on its autotrophic growth, possibly from high cell number, it started to consume organic carbon, a heterotrophic regime, entering in a period of growth stagnation and greater accumulation of compounds. For the textile cultivation, we obtain a removal of 49.2% of COD, very close to what has been found by other works, using the same type of effluent and using the microalgae Chlorella vulgaris. As for the effluent on the paper pulp, we removed 64.3% of COD, similar to that reported in other works, mainly using the microalgae Senedesmus. And regarding to the compounds detectable by the UV visible range, mainly color and aromatic compounds, they decreased by about 31.7% in the effluents. These results indicate a decrease in the color of the effluent as well as the removal of dyes, demonstrating that this microalgae Selenastrum is also able to eliminate other compounds in the addition of those detectable by the COD. As for the numbers of cells produced, the highest values achieved were for the control cultures, reaching an average of 12.3 million cells per milliliter, while cultures in the effluent reached only 7.4 million cells per milliliter. This indicates that the less stressful and more controlled environment, the greater the number of cells. On the other hand, higher dry weight values were recorded for cultures with available dissolved organic carbon and stressful conditions. Trials with these conditions had on average 62% more dry weight than the control culture. For the textile effluent, we obtained 0.42 milligrams per milliliter, which is within what is reported in other studies with the same effluent. In addition, that in the work that obtained the highest amount shown here, they mixed the textile effluent with sodium bicarbonate, influencing its final biomass. As for the effluent from the pulp, 0.47 milligrams per milliliter was obtained, a lower value than other works. However, The works presented here as a comparison, they have making a mixture of effluents from the pulp and paper and dairy industries, resulting in a less stressful ambient environment for the microalgae with more nutrients to absorb and accumulate. Now, as we consider the mass values per cell, we note that the effects of the stressful environment on the microalgae resulting in heavier cells than those found in the control assays. The timeline also suggests that after 4 days or 96 hours, the microalgae reaches its maximum metabolic production. Further studies could consider this time profile in the conjunction with the stress factors and biomass accumulation. Finally, in relation to the cell volume, we can see the difference that the combination of organic and inorganic carbon had compared to the culture with only inorganic carbon. Noting that in the graph, a considerable increase in cell volume in the first hours of cultivation, only with the contact of microalgae to the environment rich in organic carbon. It's also interesting to note that the cell volume has the same order of magnitude between the effluents and the glucose assay, with the latter reaching the highest volume. However, remembering the previously seen values for the weight per cell, cells grown in effluents were heavier. So we can say that the microalgae in the glucose assay were larger, but lighter than those grown in effluents. This effect of glucose in increasing the biomass of the culture was also observed in other studies, resulting in an increase of 0.25 milligrams per milliliter in the final biomass for the microalgae Chlorella vulgaris and Clabinomonas reinacti. Also, emphasizing that other works have reported a lipid content of at least 14% in the microalgae Selenastrum, indicating a potential future of use of these compounds for the production of biofuels. In conclusion, this study can demonstrate the capacity and potential of the microalgae Selenastrum sp in the treatment of effluents from the textile and paper pulp industry. The biochemical conversion of compounds dissolved in the effluent resulted in an accumulation of biomass compared to that one found in the glucose assay. And its growth and accumulation of biomass suggests a greater potential for future use in biotechnological purpose. I also want to emphasize mainly the results obtained in the effluent of the pulp paste, where there were a greater accumulation of dry biomass and COD removal. These were the references used in this presentation, and again, thank you for your attention.
Good day. My name is Anabela, and today I will speak about water reuse and risk assessment for water resources. But why water reuse? The increasing water demand for multiple purpose and for diverse activities is plus the adverse effects of climate change is increasing pressures over water bodies. So therefore, new alternative water sources are being searched and are being used as a part of the solution to for a new approach on the water resources management to namely to minimize the adverse effects over the freshwater consumption. In this way, several studies and standards were being developed for water reuse, namely the international standards from ISO that started to define specific standards for water reuse for multiple purpose, irrigation, urban uses, industrial uses, always based on a fit for purpose approach. What it is a fit for purpose? Fit for purpose is a quality of the water that meets the end user's requirements, plus without jeopardizing the risks for risks for human health and environment. In 2020, the European Union proposed a regulation for water reuse, namely for agricultural irrigation from urban wastewaters, treated urban wastewaters. But a little bit earlier in Portugal, we developed a legislation for multiple water reuse purposes from several wastewater sources. And it is the decree law 1129 plus Dutch 2019. Both EU and Portuguese legislation are based on this fit-for-purpose approach from ISO, so they all follow the same approach. And one of the main purposes of this approach, one of the main supports of this approach is all projects must follow a risk assessment procedure, and the risk assessment procedure for human health and environment. Some projects are already being proposed for human health, but attention is being paid for environment, namely for water resources, and therefore that's what we intended to study. We intended to study, and we are presenting. So the aim of the study was the development of a site-specific knowledge model applicable to water resources, both surface or groundwater. And the main support of the project, of the model, is a typical tire approach based on the hazard identification, pathway and exposure assessment, and risk characterization. It's a model to deal with the nutrients and compounds of emerging concern, disinfection byproducts, other chemicals like priority substances, which are substances that are classified as toxic, persistent, and with potential for bioaccumulation, and are legally with the legal requirements under the Water Framework Directive, and therefore member states need to reduce or even eliminate emissions, discharges, or losses from this kind of substances. So the basic methodology is risk characterized by the product, hazard versus vulnerability versus damage. So regarding the model, like I said, is a conceptual model. On the first phase, we identified hazards, so chemical substances and nutrients or nutrients. On the second phase, we are going to look at exposure and pathway assessment. So we are going to look at the vulnerability of the groundwaters and surface waters. Plus, we will interlink, we will co-correlate with the barriers in place. Barriers are measures to reduce the contact of the water, the reclaimed water, and the water body. However, in case of failure of the barrier, we may have an additional scenario, scenario of contamination, so an additional pathway. So we will correlate the vulnerability, the specific vulnerability of the groundwaters, plus the barriers in place to find a global vulnerability. And afterwards, we're going to look at the damage. What is the severity of the damage? What kind of damage we may be in presence, and finally we will determine the risk level. After that, we will define control and minimization measures, and on strategic assessment, we will reassess the risk to ensure that the measures that we are taking into account are really reducing the risk, or at least keeping at the same level, but not increasing. And after the final solution is found, we can run our project with by managing risk. All criteria and factors of the process are classified according to an importance scale from values 1 to 9. So for hazards, we defined two scales, one for nitrogen and phosphorus, other for other chemicals like compounds of emerging concern, disinfection byproducts, priority substances, and other ones. So where substances are classified from 1 to 9, so the criteria 1 to 9, and for nutrients we are going to look at the level of treatment in place, so the level of removal of nitrogen and phosphorus, plus the characteristics of the water body, which means we are looking at if it's a vulnerable area for nitrate pollution. So if we're talking about areas where nitrates are a complex problem, substances, areas where are in risk for eutrophication, and also the status of the water body. What is it? The status of the water body. Status is defined according to the principles. It's the principles of the Water Framework Directive, where the main goal is achieve the good status. For surface water, we're talking about ecological status and chemical status, and for the groundwaters, we are talking about chemical status and quantitative status. And this quantitative status on water groundwaters are linked to the ecosystems depending on groundwater. So when groundwater arrives surface, could promote ecosystems, like for example, that we have in area of springs, and therefore, so we need to have enough groundwater to ensure this the life of this kind of ecosystems depending on groundwaters. For the other chemicals, we are going to look at the environmental quality standard, which is the binding value, the legal requirement for that the substances needs to the parameters needs to be complied at the water body. And in a lower level, we are going to look at limits of quantification and limits of detection. We are talking about hazardous substances, so we are talking about very low levels. Where are we going to look at our data? We are going to look at our data on permits, self-monitoring programs, projects, also data from inspections, data from the river basin management plans, where the status of the water body is classified. So is a source where we have a lot of data from monitoring on water bodies. Also on, for example, if we're talking about urban wastewater treatment plants as a source of our reclaimed waters, we may look at European pollutant and transfer register, and also data from academia, like research projects, namely projects that are being developed in our local, in our region, in our country, and also other monitoring data, like for example, the National Information System for Water Resources. So after hazards, we are going to vulnerability, and on the first step of the vulnerability, we are going to look only on the characteristics of surface water and groundwater. For that, we are going to use this matrix. This was adopted from the standard, from the part 1 of the standard 16075, and that correlates the characteristics of groundwater versus surface water, which means, like, for example, in the areas where I have a high infiltration rate, so I have a low runoff, and vice versa. So therefore, we develop an algorithm for this, for the vulnerability of the water resources, where the partial vulnerabilities for groundwater and surface waters are directly achieved by the look at the matrix, and the weighting factors are also given by the values from the partial values from the matrix. Which means that, so I have a value, a final value that is weighed according the water resource with more pressure, ground or surface water, according its characteristics. After we find the value for vulnerable water resources, vulnerability of water resources, I will transform it into, I will prioritize it into the importance scale according the table below. So for the global vulnerability, we are going to look, like I said before, at the barriers. Barriers could be partial retention, total retention of the reclaimed water, capacity, a system according, so the irrigation system according the water crop needs. So these barriers were developed according the knowledge of reuse projects, namely, for example, irrigation projects, and literature in place. And also we are going to look, when this barrier fails, I may have a pathway of contamination. So I may have a scenario of contamination. So every failure may count as a scenario. So we also developed a table for the number of scenarios linked to each barrier in place. And with this, we can find the global vulnerability. After vulnerability, we need to look at damage. And for the partial damage, damage is linked with the failure of the barrier. So each failure may produce a type of damage. And each failure has a probability of occurrence. And depending on the barrier in place, I may have a different severity of the damage in place. So for each barrier, I can calculate a partial damage. This partial damage is calculated directly through the use of this matrix. This is very usual matrix is used in risk assessment, likelihood versus severity of damage. And for the probability of the failures, we used a scale used on other risk assessment models, namely the model for human health risk assessment from the ISO, from ISO 20246, and also for the barriers, for the severity of damage. We are going to look into, once again, since we are talking about water resources, we are going to look at what's the characteristics of water resources. So once again, the status of the water resources, the good status of the water resources is at risk or not, or is less than good or not. What are the water resources is classified as vulnerable to nitrate pollution, or as a sensitive zone to eutrophication, or due to a specific use, or do I have specific uses on the waters, like for example drinking water supply, recreational waters, bathing waters, fishing, and so on. So linked with all of this, once again, I will look at the data from the data sources is the same that we use from the hazards and from the local characteristics. So taking into this account, I can calculate the partial damages, and after the partial damage, I can integrate it into using by this equation and find the total damage. So with the total damage, I can finally calculate my risk and normalize to the maximum value of the importance scale 9 to reduce the scale, and finally prioritize the risk into 3 levels. And if I have an acceptable level, so the risk, so the project cannot be accepted, at least we need to improve treatment or act on barriers, and therefore reassess the risk to reduce it to an acceptable or despicable level. If I have an acceptable, it's important to define a quality standard for that kind of substances that represents my hazard in assessment, and for despicable values, probably no quality requirements will be needed, only monitoring. So after the development of the model, it was applied to a case study, a golf course that intended to use reclaimed waters for irrigation. The location, it's an area classified as vulnerable to nitrate pollution. The hydrological characteristics is a local with high infiltration rate for groundwaters, where there's an aquifer with some protection in the area of the field. The aquifer is classified also as a strategic reserve for public water supply. The water status of the water body, both surface and groundwaters, are good status. And we know that the wastewater treatment plant in place is as a secondary level, plus disinfection UV. And also we know that from the pollutant releases and transfer register, we know that we have phthalates below limit of quantification. Why phthalates? Because it's a widely used substance at urban level. So it's usually is a substance that is discharged in the domestic and urban wastewaters. So it's not only correlated with industrial uses, but mainly nowadays to the domestic uses. The widely presence of plastics. And so we need to take into account these substances. It's also classified as priority. So what our questions are: do we need to improve treatment for nitrogen or phthalates removal? So we need to improve this treatment. Is there a need to establish a quality standard for nitrogen and or phthalates? So let's look and let's put our results into our equations and find the risk value. So all the data, once again, came from the sources that I presented before. Plus, if we have additional requirements, we can also use the local authorities that are responsible for the management of water resources, because they have a high knowledge of the water resources at the local regional levels. So in Portugal, the River Basin District administrations from the Portuguese Environment Agency. So for nitrogen, so secondary level, so no removal of nitrogen. So the initial hazard is 9. The global vulnerability, taking into account the characteristics of the water bodies, surface, groundwater, plus barriers in place, it's a 7, or the absence of barriers is a 7. The damage is 1. So the risk level for nitrogen 9 is 7, which is an acceptable level. So that means that we need to reassess. So we need to remove nitrogen. So we can reassess and we can go to a 7. And why a 7? Because in our table, we need to take into account it's a vulnerable areas to nitrate pollution. And when we reassess with this level, we found an acceptable level. So yes, it could be accepted, but we can reassess again to a lower level. And we can reassess only for the hazard 1. Why? Since it's a nitrate pollution area, I cannot put it on the level 5 or 3, because those values are for for areas non-vulnerable to nitrates. So, but if I look at this hazard 1, I will have a despicable level with a very low level of risk, 0.8. So when I look at this acceptable despicable level for nitrogen, I may find that perhaps an intermediate value for removal of nitrogen could be accepted. Let's look in detail in the next slide. But now for phthalates, I have a 5, so hazard 5, so it's below limit of quantification, 5, vulnerability, global vulnerability versus damage 1 will be an despicable value. So for phthalates, below limit of quantification, it's the expected value despicable. But let's look once again to what it really means. So when I look at nitrates, nitrogen, I have to take into account that probably, yes, I need to define, I need to improve my treatment for nitrogen, so I will need to remove nitrogen, but to define the real level, I need to make a balance with the what are the crop needs, what are the in terms of fertilizers. Because part of this nitrogen that are unreclaimed waters can be used by crops. So, and I must ensure that I'm going to use it. Otherwise, I will remove it from one side and add synthetic fertilizers by another, which is not the best solution, of course. So therefore, we need to balance, because we have to take into account that not all kind of nitrogen is absorbed by crops. Only inorganic nitrogen can be absorbed. So we need to ensure that we have the right treatment with the right levels of nitrogen with the right balance to minimize the use of synthetic fertilizers and maximize the use of the nitrogen from reclaimed waters for fertilizing the crop. In terms of the phthalates, what I need to take into account is for this kind of substances, phthalates, and it's even worse if I go to some kind of antibiotics or hormones or medicines or biocides, I must sometimes the limit of quantification that are usually used are higher than the EQS. So if indeed the limit of quantification is lower than the EQS, then I will have a despicable risk level, and therefore, besides monitoring, I don't need additional treatment or additional measures. But if my limit of quantification is higher than EQS, then my hazard is not a 5 but a 9, and therefore I will have an acceptable level of risk. So do I need to remove phthalates? Perhaps yes. But once again, here, the treatment for this kind of substances is not easy. If we're talking about physical treatments, I'm just putting from the liquid phase to the solid phase. So I'm transferring the problem from the reclaimed waters to the sludge, which also needs to be balanced. If I have chemical treatment, I have the production of byproducts, which could be more toxic than the original ones. So in reclaimed waters, sometimes what is used is the blending. So not only improve treatments, but also blending. Why blending? Blending is also used to adjust micronutrients like potassium, sodium, chlorides, and which are needed for the crops, but not in high levels or disadjusted levels. And also sometimes, in the majority of the cases, the reclaimed waters are not enough to suppress the watering demands of the crops. So blending is a very useful and usual method to reclamation processes to promote an adjustment of the water quality and an adjustment of the water quantity. So final remarks. So the main strength of the proposed model, it's its simplicity and easy outputs. And also the data source are usual data that are available, public available. The application of a case study allowed to demonstrate its applicability and the strengths of the model. It's a useful tool to help authority on the validation process of the appropriate quality standards to be noted on the water reuse permits, and also on the definition of control measures and minimization measures of the risk, namely due to the strategic assessment in place, so the need of the reassessment of the risk every time we do an additional measure. In terms of nitrogen, we have to take into account the needs to balance with the needs of fertilizing, to ensure that we are reducing nitrogen only to the needed value. And for chemicals, we need to special attention should be paid to for the limit of quantification, to ensure that I'm using adjusted ones and not values above environmental quality standards. So thank you very much. So acknowledgements for FibEnTech, FCT, and also the Portuguese Environment Agency. And thank you very much for your attention. And if you need additional questions, please just email me. Thank you very much.
Hello everybody, I'm Faléstine Souiad, PhD student at Consortium University from Algeria. First, I would like to thank the organizing committee of the first FibEnTech International Conference for accepting my work to be presented as paper in this conference. And I have honor to present my work for you today. My presentation will structure as follows. I will start with the introduction, explaining the problem posed by this work and its aim. I will pass the material and method that were used to perform this work, and after that I will discuss my results for you, and I will finish my presentation with the conclusion summarizing the most important results obtained. In natural aquatic ecosystems, groundwater presents high concentration of calcium and magnesium, which leads to a natural spontaneous formation of undesirable scaling deposits on surfaces. These scaling deposits are mainly due from the precipitation of calcium carbonate, which cause various undesirable effects. The formation of those insoluble mineral salts almost totally block the water distribution pipelines or the cooling water tubes, reducing the flow rate. Moreover, the scaling formation significantly reduces the water treatment technology's efficiency and of the desalination and water softening system. Research to find new inhibitors compatible with the environment is underway using the so-called green inhibitors, according to three criteria: toxicity, bioaccumulation, and biodegradation. To go further with this aim, this work focuses on new bioinhibitors for reducing the scaling deposit formed by Bonwara groundwater, which supplies the entire southern region of the Constantine city in Algeria, and is unfortunately characterized by 60-degree French of hardness. The inhibitors used in this study were the tomato and strawberry leaves as economical and bioinhibitors for scaling inhibition in Bonwara hard water. Strawberry and tomato leaves were collected from a greenhouse in Jiju city from Algeria. After collection, they were washed, dried, and crushed into powder to be ready for use. The extraction was performed by adding 100 ml of boiling distillated water to 5 grams of leaves and leaving them for 15 to 20 minutes to infusion. After that, they were filtered with a paper filter to obtain an extract of 5% mass volume. The electrochemical tests were carried out in a thermostated double-walled conventional 3-electrode glass cell with a capacity of 500 milliliters. Before each experiment, the cell was cleaned with ethanol, rinsed with distillated water, and dried. A saturated caramel electrode was used as a reference electrode, having a platinum wire as the auxiliary electrode. The working electrode was a stainless steel electrode made of XC10 with 1 cm square of active area, embedded in inert resin. The surface of stainless steel electrode was polished before every assay with abrasive paper, cleaned with acetone and rinsed with distillated water. The electrodes were centered in the electrochemical glass cell at a constant distance, connected to the Potosiosta galvanostasra, controlled by gamma ray analysis software. The experiments were operated in batch mode for 60 minutes, applying a potential of -1 volt versus saturated caramel electrode. The tests were run at 20 and 40 degrees, utilizing 400 milliliters of Bunwara raw water in the absence or in the presence of strawberry or tomato leaves extract. Solutions were continuously stirred during the experiment and at 500 rpm. Figure 2 presents the colorimetric curves of Bunwara water in the absence of the inhibitors at different temperatures. The curve represents the resultant current density as a function of time during scaling deposition. According to Lydian, the scaling power of water can be characterized by the scaling time and the scaling index values obtained from the colorimetric curve of this water. The scaling time corresponds to the minimum time needed to obtain a residual current, which remains stable after that time. The scaling index is calculated from the scaling time according to equation. From the slope of the linear part of Bunwara water curve at 20 degrees, figure 1, it can be seen that Bunwara water has a scaling time of 16 minutes, with a scaling index of approximately 64 minutes minus 1. According to this value, Bunwara raw water can be classified as very hard scaling forming water. Comparing the curve shape of Bunwara water at 20 and 40 degrees, it can be observed that temperature has a favorable role upon scaling deposition. The scaling rate increases when the temperature was raised from 20 to 40 degrees. The scaling time decreases from 16 minutes to 8 minutes. The residual current also decreases, and Bunwara water becomes more scaling forming water at high temperature. To study the effectiveness of tomato and strawberry leaves in inhibiting the formation of calcium carbonate, the colorimetric assays were carried out for Bunwara water in presence of various concentrations of inhibitors extract at 20 and 40 degrees. The efficiency of inhibitor is calculated according to equation 2. Figures 3 and 4 present the colorimetric experiments realized at different concentrations of strawberry leaves extracts for inhibition calcium carbonate formation. The scaling time and residual current increases with inhibitors concentration. When 1 ppm of strawberry extract was sufficient to change the shape of Bunwara raw water curve, the scaling time increased from 16 minutes to 25 minutes with efficiency of 31%. And the residual current increases from 20 to 31 microampere. The scaling time and the residual current keep increasing with the strawberry leaves extract concentration. For 15 ppm of strawberry leaves extract at 20 degrees and 30 ppm at 30 degrees, no current reduction was observed, and the scaling time became undetermined. So, it can say that at these concentrations, the scaling formation was totally inhibited. Tomato leaves extract has a similar effect on the scaling time and residual current as shown in figure 5. However, its efficiency in calcium carbonate inhibition is lower, since it reacts with higher concentrations when compared to strawberry leaves extract. The total inhibition was obtained at 20 ppm, as shown in figure 6. At 4 degrees, similar behavior is observed. The residual current increased with the inhibitor extract concentration until reaching a constant value of optimum concentrations. Since Bunwara becomes more scaling forming at 40 degrees, the extract seems to be less efficient at higher temperature, when higher concentrations were necessary to attain the same rate of inhibition obtained at 20 degrees. The effect of strawberry and tomato leaves using impedance metry was characterized by charge transfer resistance values, which were obtained after polarization of the stainless steel electrode in the absence and in the presence of the bioinhibitors. Higher transfer resistance indicates that the formed scaling is more compact, and the surface of stainless steel electrode is highly covered by the calcium carbonate crystals. The rate efficiency is calculated from equation 3. In the absence of the inhibitors, the impedance diagram consists of two loops compared with curves obtained in the presence of strawberry and tomato leaves extracts, where the first loop completely disappears. According to Gabriele et al., the existence of two capacitive loops indicates the presence of the calcite crystals on the surface of the electrode. It can also be clearly observed that the diameter of the diagram's loop is decreasing as extract concentration increases, due to charge transfer resistance decreasing. In fact, charge transfer resistance of Bonawara water is 8,980 ohm, and this value decreases more than 58% in the presence of 5 ppm of strawberry leaves extract to become 3,815 ohm. The addition of similar concentration of tomato leaves extract, figure 8, decreases the charge transfer resistance value to 4,175 ohm with an inhibition of 52%. The minimum values of charge transfer resistance were obtained in the presence of 15 ppm at 20 degrees in the case of strawberry leaves extract, and at 20 ppm for tomato leaves extract. These concentrations were also the optimum concentration in chronometric curves, so the results of impedance metry are in agreement with those from chronometry. The effect of temperature is noted on the impedance diagrams, being the charge transfer resistance decreases at 14 degrees, observed for higher concentrations. From the results obtained, we can conclude that the inhibition of scaling formation on stainless steel electrode from Bonawara water using agricultural waste was accomplished with success. The electrode surface is uncovered with the scale particles in the presence of strawberry or tomato leaves extract and an appropriate concentration. The results obtained show that the aqueous extract of strawberry leaves is more effective than the aqueous extract of tomato leaves because it acts at lower concentrations. The anti-scale capacity of tomato or leaves extract are higher at lower temperature, though the temperature and the inhibitor concentration influence the kinetics of the scale deposition. The inhibitory effects of Naceur product, which differ from one product to another, depends on its composition and therefore of its mode of action. Recovery and valorization of agricultural waste in the treatment of hard water is a good solution to clean and protect the environment. Thank you for your listen. Best regards.
Hi, I am Josué Satro. I am PhD in civil engineer. My paper is about opportunities for microalgae-bacteria, consortium application to the treatment of effluents generated in fiber-based recycling process. This is a paper review. So to start this presentation, it's necessary to contextualize this term. With the increasing deterioration of water quality in aquatic bodies resulting from human activities, so there is a need to increase the use of process for the wastewater treatment. Now, from anthropogenic activities, for example, industrial sewage discharge, so increase the water pollution, so wastewater treatment necessary. The application of biological processes readily in the world. In this figure, we can see the mechanism between microalgae and bacteria. Where is it observed the MABA, these aggregates, microalgae-bacteria, applied stress systems, for example, sequential batches, continuous flow, head response. Regarding sustainable systems, enable more efficient and less costly techniques for the effluent treatment. These are systems that require low operating cost, low energy cost, enable the generation of water resource due to ego biomass. This is ego biomass can generate, for example, animal food, biofuels, energy production. Now, some intelligence. 30 to 30% biomass recovery cost, as well total cost to production. So some study use the method to activate grids biofocalization of biomass, for example, application chemical reagents, fungi, microalgae, bacteria, biofocalization. This is formation of MAB. We count as these pictures and bacteria in microalgae. On microalgae and bacteria begin to structure in the form of granules. So the consortium assimilated nutrients from the water. This processes ammonification, nitrification, denitrification. This is aggregates microalgae and bacteria, the mechanisms, for example. Lastly, APS are constantly key in the process of formation and aggregation of the microalgae bacteria. Now, we can observe two forms removal of organic matter. For example, 4 ways for bacteria, for microalgae. There are 4 ways of removing nitrogen. For example, remove nitrogens and ammonia volatilization, nitrification and denitrification, nitrite assimilation, ammonia assimilation, for example. Please note the phosphorus removal is major solution actually in sewage treatment. The mechanism revolves around the ability of bacteria and microalgae to assimilate and accumulate phosphorus. Another mechanism, the chemical precipitation of phosphates with a pH above 90.5. The formation hydroxyapatite, struvite. The biomass generated from the microalgae bacteria aggregates composed carbohydrates, proteins, lipids. This is lipids biofuel production, for example. So we produce biofuels. What is the world needs? This is resource gaps, for example. The application of microalgae bacteria. No, word scenario. Here you can have 2 current word scenario. For example, the world consumption of diesel was most 2 trillion liters. Researchers have predicted a growth of up to 14 in the next 20 years. Hence, there will be need for studies for clean and renewable energy potential goods. Now, is the application of MABA efficient for wastewater treatment, as well application aggregates microalgae-bacteria. Some papers, for example, domestic wastewater, pharmaceutical industry wastewater, but MABA have not yet been applied pulp and paper industry. But some papers microalgae treatment have, for example, we can observe this is pictures pulp and paper industry, industrial sewage discharge. This is characteristic is the effluents defining with a specific color, a range of organic, inorganic, continually produced. This is type industrial. Pay attention to this table. Student that applies microalgae to wastewater treatment in the paper industry. This table, type of treatment, treatment performance, microalgae species present, remakers, reference. But this is papers review notice four-line remakers. For example, treatments are sustainable based on microalgae with potential for generate bioenergy. Lastly, conclusion. Previous research showed that agro-basal technology has the potential application environment. The microalgae-bacteria aggregates consortium is able to consume the CO2 and might be the industry. This form of more sustainable consortium allows the production of value-added production, as well animal foods, biofuels, biodiesel, bioethanol, can generate agro biomass. Thank you for your time. Thank you very much, everyone. Bye.
So, first of all, I would like to congratulate the four speakers for their very nice presentations. Now I invite the speakers to join me to a short section of questions. The idea is to make 2 rounds. I hope you have time. I have some questions from the audience, and I also prepare some of them. So I will start with Bruno, and the first one is the following. I know relatively well the work, so there are some points we need to clarify. And the question is, if you have the opportunity to continue with this work, what will be the main aspect to clarify and study? That means which is the points that you need to clarify.
Okay, hello everyone. Okay, thank you. I think future projects and works would be more focused on characterization of the effluents, better understanding on everything that is diluted, and the impacts of each diluted compound in the growth of the microalgae, and also the influence of the microalgae in each aspect of the effluents.
Okay, thank you. I move to Anabela Rebelo, and the question Before the question, I would like to say that I like very much your presentation. You are a senior researcher, so is expected. But it was a very nice presentation. I'm not expert in the area, so I only have some curiosities about the work, and my curiosity is if this model, this semi-quantitative model, are being used in the field to evaluate the impacts, or it is only research curiosity. It is applied by the different agencies.
And so thank you very much for your question, and thank you for your kind words. Indeed, this model is starting to be applied in the field, namely in Portugal. However, we are starting. We wanted to include it in the guideline that the Joint Research Center from the European Commission is developing, because a new European regulation was approved last year for water reuse, for irrigation, agricultural irrigation. And therefore, we wanted to show our work to the Joint Research Center, because as far as I know, there are not a simple tool to use for water resources risk assessment. There are not available any kind of tool, and this one could be easily used, and helps authorities to make decisions. So it's give good results, taking into account the level of available data. So indeed, is already starting to be applied in Portugal, and we want it to be applied at least at European level. Thank you.
Okay, thank you. So I move to Faléstine Souiad. I suppose is there. Okay. Hello. Are you hearing me?
Yeah, I'm here.
Okay. So my question, I congratulate you about your work, very interesting work. The question that I prepared to you is about the mechanism behind the effect of these bioinhibitor scaling compounds. Do you have an idea about the mechanism involved?
Hello, thank you for your question. First, because they are the natural products, so the mechanism for now is not exactly. We don't decide exactly the mechanism, but there is some proposition like complexation. I think that these plants contain acids. So these acids can make complexes with the calcium or magnesium that are responsible for the precipitation of tartar. So the most proposed it's the complexation, or maybe they will be adsorption. Not it's not must be the complexation, but in the case of the natural products, they always propose the complexation of the composition or the molecule of the acids, like I said before, with the calcium or magnesium. This is the proposition. It's the complexation.
Okay, thank you very much.
Thank you.
I move to Josivaldo. And the question that, hello, Josivaldo.
Okay.
Congratulations for your work. The question that I prepare is the following. What are the main advantages of algae-bacteria consortium regarding the bacteria alone?
Okay, thank you. The main advantage in the increase in the segmentability of the biomass, which can generate products with which are developed biofuels and malfood, and also contribute to the cycle economy of sewage treatment. So close the life cycle of wastewater treatments.
Okay, so I move to the second round. And in the second round, I have the questions from the audience, and the The question that I have for Bruno is from our colleague Albuquerque, and the question is the following. It seems that algae adapt more easily to paper pulp effluents than textile effluents. Is there an inhibition with the presence of dyes, or as it happened with bacteria? That means the question is why textile is hard to degrade, is the question. It seems that this occurs with bacteria.
The problem with the textile effluent is that because of dyes and color dissolved in the water, makes it difficult for microalgae to obtain light for photosynthesis, thus limiting the final cell number and the proper treatment of the effluent.
Okay. I move again to Anabela Rebelo, and I will put a question that comes from the audience, from our colleague Erlin that is here with us. And the question is, despite the opportunity for water reuse, in your opinion, why do some hotels groups in Algarve invest in desalination process to have alternative sources of fresh water for irrigation and other uses?
Okay, so thank you. Hi, Professor Erlindo. Nice to hear from you. Indeed, what we need to take into account in the water, we need the water reuse is not the solution, is a part of the solution. So it means when we're talking about water resources management, we need to integrate several sources of water. So potable water, water reuse, plus additional water sources. In certain cases, certain hotels in Algarve are using desalination. As far as I know, are two. And why? Because water reuse was not available when they started to when they had the need to use an additional water source. Our legislation in Portugal is quite new, is only 2 years old, so it was from August 2019. After its publication, a certain virus appear, so it was not easy to starting to put all in place, all water reuse projects in place. But I think now they are moving. Now we are having some urban systems trying to produce water, reclaimed water for several purposes here in Algarve. I'm from Algarve, so I said here, but also in other parts of the country. One of the major projects, for example, is in Lisbon, where the water from tourism plant from Beirolas is going to be used for the irrigation of Parque das Nações. So lots of several projects are in place. And I think the hotels in Algarve, they will use a mixture of the reclaimed waters. However, we have to say reclaimed water is a limited quantity of water. So sometimes, and if we have several users, other water sources may be needed also, like desalination. Thank you.
Okay, thank you. Moving ahead for Faléstine Souiad, the following question is about the chemical composition of the different extracts, following the previous comments that you did. Do you have information about the chemical composition of these extracts to relate with the different mechanism that you suggest?
Actually, for now, no. I didn't do the analysis for my extracts, but in general, we know that aqueous extracts is contain principal vercation, maybe anion, and some acids. So for that, we suggest the complexation for suggest the mechanism, but exactly the composition is not decided, is not defined yet.
Okay, thank you. The last question for Josivaldo comes also from our colleague Antonio Albuquerque, and the question is the following. How can this bacteria-algae consortium be optimized for both obtain good production of algae biomass for valorization and have a good removal of pollutants?
Okay. It's necessary to man the optimal condition for the existence of bacteria and microalgae, which can be adjusted with control parameters such as pH, temperature, hydraulic dent time, for example. They adjust these parameters.
Okay, thank you. I think you can finish, but before finish, I would like thank everyone that participated in this section. Thank you very much, all. Before close this section, I would like to remember that the next section will start at 11:30 and will be led by Dr. Antonio Mendes. That's all. Thank you very much. Thank you.